Hey everyone, and welcome back to The Explainer. Today we're jumping into some really cool new research about how we can make our office buildings way smarter and a whole lot more efficient, especially, when they're mostly empty. We're talking about technology that can save a ton of energy and cash when literally no one's watching.
But let's just start with a super simple question, one that really gets to the heart of the whole problem. Why are we air conditioning empty offices? I mean, think about it. Why are we spending all this money to heat and cool these massive buildings when there's hardly anyone inside? Sounds kind of nuts, right? But believe me, it happens every single day. Okay, so let's get into it. The first thing we need to wrap our heads around is what we can call the empty building problem. It's almost like there's a ghost in the machine, just running up the energy bill for absolutely no good reason.
So here's how it usually works. Most big commercial buildings run their heating, ventilation, and air conditioning, their HVAC systems, on a really basic fixed timer. For the building in this study, that meant the heat or AC fired up at 6 a.m. and shut down at 6 p.m. Monday to Friday. It made no difference if there was one person in the building or 1,000. Same schedule.
And what's really wild is that this isn't some kind of mistake or a bug in the system. As the researchers over at Lawrence Berkeley National Laboratory point out, this is exactly how these systems were designed to work. It's basically a holdover from a totally different, less efficient time, and now, as we're trying to decarbonize, it's just this massive source of wasted energy.
So, what's the fix for this ghost in the machine? Well, what if we could give the building eyes? This is where the smart solution comes in, a system that can actually see how many people are on each floor and tweak the climate control in real time. The tech they put to the test is called a cloud-based optimization platform. Yeah, I know, it's a mouthful, but here's all it really means. It's like a new brain for the building. It uses AI and machine learning, pulls in a ton of data from sensors, and then intelligently tells the old HVAC system what to do. And the test for this all went down in a nearly 300,000 square foot office building in Washington, D.C. So the system setup brought a few key things together. You've got 22 occupancy counters, one for each floor. These are the eyes, the most crucial part. Then there are 50 wireless sensors checking things like temperature, humidity, and CO2. All of this gets plugged into the building's existing control system, it pulls in live weather data, and then it feeds everything to that cloud-based AI, which makes all the smart calls. So how does this AI brain actually save energy? Well, it makes three main smart moves, or what the study calls energy conservation measures. Okay, first up is optimal start, which I like to call waking up just in time. Instead of that rigid 6 a.m. start, the system looks at the weather outside and the temperature inside to turn on the HVAC at the absolute last minute to get things comfortable by 8 a.m. Second is the midday ramp down. Think of it as a smart lunch break. When it sees people leave for lunch, it eases off the fan speeds. And third, early shutdown, or putting itself to bed early. As soon as the last person is gone from a floor, it waits 15 minutes, then shuts that floor's system down. It's so simple, but it's brilliant.
In this table here really shows you how precise these little tweaks are. During that midday ramp down, we're not talking about anything drastic. Look at this. It's just lowering the fan's static pressure by a tiny bit. But when you multiply these small, smart adjustments across an entire building day after day, yeah, that's where you get some serious energy savings.
All right, now every good story has a plot twist, right? And this one is no different. The team installed all this amazing new tech in July of 2020. You can probably guess the complication. The world had just turned upside down, and suddenly, all the offices were empty. And when I say empty, I mean empty. The drop was just dramatic. Before the pandemic, the building was at 100% occupancy, but during the test period that summer, it was down to just 5%. And you could imagine, this was a massive headache for the researchers. Which brings up a huge question. How on earth do you test a system that's based on occupancy when there's no one there? I mean, you can't just compare the 2020 energy bills to 2019's, right? The numbers would be totally apples and oranges, completely useless. So this is where the scientists got really, really clever. They used what's called a calibrated simulation. Think of it like creating a digital twin of the building. First, they grabbed a full year of normal pre-COVID data from 2019. They used that info to build a super detailed computer model, and then they tweaked that model until its energy use was a perfect match for the real 2019 building. Then, and this is the brilliant part, they added the new smart tech to the virtual building and ran the simulation to see what would have happened in a normal, fully occupied year. Okay, so with this digital twin running, they could finally get some real answers. This is where we get to uncover the numbers and see the true potential of this kind of technology in a normal, bustling office. So this is the big one, isn't it? If that building had been full of people, just like normal, how much energy and how much money would this smart platform have actually saved over an entire year? And the answer from that simulation is 6.1%. That's the total savings on the building's energy bill for the entire year, just from those 3 smart strategies working together. And that 6.1%, what does that look like in actual dollars and cents? Well, it translated to over $23,000 in savings for the year. I mean, from a business perspective, that's a pretty significant return. And that's just for one building in 1 year. This chart breaks it down for us. It shows exactly where those savings came from. The biggest chunk, by far, 3.4%, came from that early shutdown. Just common sense, right? Turn things off when people go home. The next biggest piece, 2.6%, was from the optimal start, not waking the building up too early. The lunch break ramp down was much smaller, just 0.1%. But hey, every little bit adds up. So let's zoom out for a second, because this is really about way more than just one office building in DC. This is about creating smarter buildings for a greener planet, and it really shows us a practical way to get there. You know, one of the key takeaways here is just how quickly this can all be done. The whole process, from installing it to letting the AI learn to final testing, it all took just 4.5 months. And the study points out this is a marked improvement over older optimization systems that could take 6, even 12 months to get up and running. And this, right here, really gets to the heart of it all. As the researchers say, if we're actually serious about meeting our climate goals, we need new, smart, and radical ways to cut the carbon footprint of the buildings that we already have. And this technology is a perfect example of that kind of advancement in the real world. So, we'll leave you with this final thought to chew on. This study was all about HVAC, but what else could we do if every single building knew, in real time, who was inside? The researchers hint at things like smarter ventilation, or maybe even customized airflow to individual desks. The possibilities for creating buildings that are truly responsive, efficient, and comfortable, well, we're just scratching the surface. Thanks for joining us on The Explainer.